Hi, everybody. Welcome to Dart 3 for Flutter developers. My name is Marya. I am the technical writer on the Flutter and Dart team at Google, and I wrote the documentation for Dart 3. I worked on this talk with my teammate Eric, but he couldn't be here. But it was actually his idea. He has noticed, and as have I, that like our users and even engineers on the Flutter and even on the Dart team aren't really like utilizing these Dart 3 features to their full extent because it's new and it's kind of confusing. So we thought it would be a good idea to like teach you guys that these features can actually like make your code easier to write, shorter, neater, sometimes more powerful. And so we're gonna get into it and see if you guys can take anything from this and make your code better. But Eric's not here, so we don't like him. First I'm going to introduce the new Dart 3 features to give you a little background before we get into like the actual examples in our code. Has anybody used Dart 3 yet? Oh, okay, yeah. So it's possible that like obviously every single person upgraded to Dart 3 when that became the latest version, and now we're on 3.1. But it's also possible that you haven't use the features to, again, like to their fullest extent, like I described, which is kind of the nice thing about Dart 3. You can upgrade the language version, but you can keep using Dart exactly the same way that you always have. These features are just there if you think that they make your code better, but they add a lot of variety, and I'm going to try to convince you that they do make your code better. So we're throwing around this word functional. And I'm going to kind of explain very briefly why I've been saying that and talk about, what this means for the language. So the examples in this talk are set up to kind of showcase this like old versus new. We actually first started by building our sample code without Dart 3, or with Dart 3 just not using any of the new features, which means normal Dart stuff like making objects to group our data and pass it around, telling the program to like do this, do that, step by step, and using conditional control flow to account for like any variations in those steps, which is all fine. Class-focused imperative style is how Dart and how all object-oriented languages work, and it's often the best tool for the job. But now in Dart 3, we have some like other new tools for the job, and we found that these other tools can actually improve the way that we write app code. And when I'm talking about other tools, I'm talking about functional style language features or functional language features. But as someone who's used to object-oriented programming, like also Eric is or was, and I'm assuming a lot of you are, what does functional mean? Like, what does it mean for a language feature to be functional or functional style? I think of programming in terms of all those traits that I just described, like objects and control flow, et cetera, et cetera. But I think it's interesting, or it makes Dart 3 more interesting to at least surface level understand what it means for a language feature to be functional, because it kind of like makes you appreciate how interesting Dart 3 is and all the heavy lifting that these code structures or these new features can do for your code. But since I'm definitely not an expert, I'll keep this quick and high level. Is anybody like an actual functional programmer? Does like anybody use Haskell or Rust or anything? Phew, oh, one person. You should cover your ears. So yeah, functional programming, a programming paradigm where programs are constructed by applying and composing functions. Thanks, Wikipedia. I've read that article a lot this year, and that sentence doesn't feel really helpful to me. But basically what it's saying is that it's just very function-centric, like everything's a function in a functional language. And the other important part is that functional languages are not like object-oriented languages where you're describing everything step by step. And this is called like the imperative paradigm, like telling your program what to do. And what they do instead is describe like the logic of what you want to happen or the end result, and then just let the values that flow through that logic determine what actually ends up happening, which might be kind of hard to conceptualize, but you'll see what I mean when I start showing you the new features. So is Dart a functional language now? Absolutely not. We're not trying to make it a functional language. In fact, it's so object-oriented that even the functions are objects. But like many other object-oriented languages, Dart has been incorporating functional features over time and becoming more and more multi-paradigm. Why? Just because functional languages have some great features, and it greatly expands the options you have when it comes to how you write your code. So in fact, you're probably familiar with some functional features already if you use Dart and Flutter. Functions like map and where that let you iterate over values in a collection and apply a function to each. In the same vein, collection if and collection for, again, just making functions easier to use, also borrowed from functional languages. And Dart supports higher order functions like closures and callbacks, which make it possible to pass functions around as arguments. Like set state, for example, if you use Flutter, obviously you know set state, so you've already used functional features. So since all of those are so great, the Dart language team decided, why don't we add even more functional features to Dart? And this time they added some pretty major ones. So we added patterns and records and sealed classes, and we updated our switches. I'm calling these major because now we're not just using features individually to accomplish individual tasks, but you can actually combine these features to start designing or re-architecting your code in a functional style, which gives you the best of both worlds. You can use all the powerful object-oriented stuff that Dart can already do, and if it makes sense for your code, you can also use these functional styles. So let's get into some interesting examples that are very relevant to app development and handling data that use all of these features. For the bulk of the talk, I'm going to be going through these examples, so I'm just going to really quickly talk about this hypothetical app that Eric came up with, because some of the, just to set the stage for the rest of the examples. So we made a quiz game app, and we were actually supposed to play it, but because Eric's not here, we couldn't play it, so you just have to listen to me talk. So there's different kinds of questions. There's text questions and image questions, and there's different kinds of answers as well, like multiple choice answers and Boolean answers. And then it shuffles the questions, and there's scores and leaderboards and stuff like that. The important part here is the different question and answer types, and that's what most of our examples are centered around, because the widgets to display them are different. Like obviously displaying text and displaying an image just has to be different. So most of the app code revolves around how do we figure out from our data which type it is, and then tell our Flutter app to display that type. So both the question and answer types are all subclasses that extend a common base class. So we have our text question, image question, Boolean answer, multiple choice answer, etc. And then answer is a property on the question class. The app populates the question instances with data stored in Firestore. And so when we query it, it looks like this. Again, there's our important question type. And again, because answer is a property on question, that is in the document as well. So that's the basics for the app. Now let's get to the actual code. So I'll be showing the pre-Dart 3 version of how we solve these problems, and then the way that we refactored it with Dart 3. So first, when you're working with data, it's important, especially when you're getting it over the network, to thoroughly validate it before passing it on to your app. Obviously, I don't need to tell you guys that. And realistically, you should be doing it pretty thoroughly. So this was our first draft of validating that really simple question and answer data from Firestore. It's a lot of code. It doesn't need to be this much code. It was our first draft. Obviously, it's too messy for how relatively simple that data was. But this is legitimate validation code in terms of using regular Dart, imperative paradigms and control flow. We're checking all the map data things that you should check, like that we have a map, that the keys in the map are the ones we expect, that the value types are the ones we expect, etc. So we redid it a little better. Does this look familiar to anybody? Do we write our validation code like this? If type, if this, this is just what we do. We're iterating over the documents from Firestore and pulling out the questions, and then using conditional checks to ensure that the structure is what we expect. So specifically, individually validating that every key that we want is there, and then validating the types that we want are there. And again, there's those important question types. And since the answer key is also in that data, we have to then recursively go through and validate all of the answer keys as well. And then only after thoroughly doing all that validation can we decode it and send it to our objects for the rest of the app to use. And of course, else for all the exceptions that just in case we missed something and something slips through. So this is like normal. This is just how you do JSON validation, I guess. But now with Dart 3, we think we can do it a lot better, actually, and that's what we're going to see. So we improved our JSON validation using a new Dart 3 feature called patterns. JSON validation in any kind of like long chained if-else conditional type test is a really great candidate for refactoring with pattern matching. So now our validation looks like this. That's it. It's much shorter, neater, easier to read once you know, or once you can understand them. So let's get into it. But first, like, what is a pattern? Has anybody used patterns? Oh, okay. So see the difference between the people, like all of you use Dart 3, but not all of you have used patterns. So yeah, this is what I'm talking about. Like, the features are there, but you don't have to know how to use them. You can keep writing Dart code, but they're interesting. So a pattern is like a category of language, like a statement or an expression. And it represents the shape of a value. And then pattern matching is when you compare values against that shape to see if they match. And then you can do something if they match. So zooming in, we're going to take one of the cases from our pattern matching. We have one for text question and for image question. But looking at the text question one, we're going to zoom in on the pattern that matches if our document data is a text question and then returns a text question object. So first, before we get into the pattern itself, one thing to notice here is that we're using a switch expression. So like all expressions, we now have switch expressions in Dart, and they can return results directly anywhere you would use an expression. So this one is written right into the return statement. And also notice that there's no case keyword for switch expressions, which is just part of the effort to make Dart 3 really neat and clean and easy to write. So now, in switches, both switch statements and switch expressions, every case is a pattern. So if any of you have used a switch since you've updated to Dart 3, you have been using patterns. Maybe you're just not aware of it. So this is a case pattern. If the case pattern matches the object that we're switching on, then it returns the case body as the result of the switch expression. So zooming in on the pattern itself, let's see how pattern matching actually works. So this case is a map pattern. It has the same structure as a map, which is kind of the cool thing about patterns. The pattern itself mirrors the way that you would create this data if you were writing it out. So you know exactly what you're looking at. So this first question is saying, is our JSON object a map? Because it sees those curly braces, and that means a map. And if it is, then it goes further in and starts iterating over the key value pairs. So does JSON have a key named type? And does type have the value text question? So the string text question here is a constant pattern, so it means it has to match that exact value. So just this first line of code here is the same as writing out all of that JSON validation from our original type checking and value checking and everything. So then the pattern goes on to match the rest of the key value pairs. But here, it doesn't need to match an exact type. It's just matching against these types. Or sorry, it doesn't need to match an exact value. It's just matching against these types. And that's because these are variable patterns. So what variable patterns do is they allow you to destructure the data. So here, destructuring means that you are taking like the full block of data, our JSON object, and pulling out individual values into new variables. So these lines are saying, like I said, they're doing the same type validation, checking that it's a string, that answers a map, that question body is a string, et cetera. but they're also then doing all this variable declaration work all in the same line. So it's declaring new variables. Variables destructured in case patterns are then usable and in scope in the case body. So you can, declare them, get them like instantiated right there, and then pass them to the case body altogether, which becomes the result of our switch expression, which in this case is the return value of our function. So we only showed you one case, but that was for our text question. We did the same thing for image question, and then we did the same thing for the answer data in its own class. So think about that, all those lines of JSON code that I showed you on that first slide. This is replacing all of that. In a single structure, we're able to validate the shape and the contents of this JSON map, extract the data that we need, decode it, and pass it to the object constructors. So now you've seen how switches and patterns make validating JSON data a lot better. I'm going to take a few of those concepts that we just learned and, again, kind of like replace all the conditional type testing with a more compact functional style. So let's start getting our data to Flutter so Flutter knows what to display. So this is our pre-Dart3 version again, and this is just a method that's called from the build method when you pass it a question object so that it can render new quiz questions. And it determines, again, based on the subtypes of the question and answer combinations, which widgets to render. The way we wrote this method, though, is a little problematic. It's error-prone, first of all, because there's so many different combinations of possible question subtypes and answer subtypes. It just relies on me as the programmer to make sure that I didn't miss anything or write any duplicate checks or whatever. And it's a lot of cases. Also, it's not so great because it's returning a column, which we did because we wanted to orient this data or these widgets vertically anyways, but returning a column isn't so flexible. Like, what if you wanted to return it somewhere where it was already inside of a column? That might lead to everybody's favorite infinite height error. So what is the best way to return two values from a function that are of different types? I feel like what we usually do in object-oriented programming is we create some arbitrary object to group them together, and we have to write a constructor and declare fields, et cetera, et cetera. You could also, I guess, like stuff them in a list, but then that drops their individual types on the floor, which means you would have to recast them wherever you use them, and you wouldn't necessarily know what types they were supposed to be. Like, that's the point of this method, is to figure out which widget types. So obviously, we refactored it with Dart3 and made it a lot better. First of all, you know it's better because I can fit it all on one page. I didn't even show you all the if cases for the previous version. And this is very similar to our JSON validation example from the last part. We're using a switch expression again, and we're simultaneously like matching over objects and pulling values out to populate some constructors. There's a few new twists here, though, that help us, one, deal with the multiple return problem that I just described, and also this is different because here we're switching over an instance of our question class and not just any old type like we were before. So first, let's talk about the multiple return problem. So our method here, using Dart3, returns a record. That's a record. There's another new feature in Dart3 that is inspired by both records and tuples from functional languages. Records group together any number of objects, and they can be different types as well, which makes multiple returns possible in Dart3 because you can just return them from any function just like that. And then the syntax is just parentheses, like a list, except not square brackets, it's parentheses. So you see it here in our return type annotation and also in the return value. So on the caller side, records can be destructured, again, using a record pattern in a variable pattern. So this is calling the question and answer view function, and then like right in the function call, pulling out the values of the question and answer properties and creating new variables that you can use that are in scope locally. And you can just use them. You don't have to declare anything new. You don't have to typecast them or anything like that. Because records don't drop their distinct types, like I said, you don't need to typecast them. So it makes it a lot easier to return things from functions and makes functions more usable in general. So that was our multiple return problem. Dart 3 also gives us a way to make objects and objects more usable with all the new features. So let's see how that works. So zooming in again on the case so we can see what's happening here. Recall that in the last example, we used a map pattern because that's just a good way to represent JSON data. But here, we're switching over an object or an instance of our question class. And so what we're using is object patterns. Object patterns match against instances of classes to see what type they are. And then they can also recursively match against any properties of that type. So here we're checking if this property has this type. And then you can use that destructured value in your case body again. Since it's so common to declare a local variable with the same name as the getter of the whatever value you're getting it from, the colon type name syntax here is the same as writing it out in the long form. So these two statements do exactly the same thing. It's just another way to write things nicer and neater in Dart 3. So like we did with the map pattern, let's go through and see how this pattern is exactly matching. So the first thing it's doing is saying, is question an instance of text question? And if it is, does it have a property that's type multiple choice answer? And does that property have the getter name answer? If all that's true, then create a new local property of the same name and give it the same value. So then we use that destructured answer property plus the question object we're switching over and instantiate the widgets associated with those types. So for example, if text question Boolean answer matched, then we instantiate our text question widget and our Boolean answer widget. So it's interesting how these features like pattern matching and our switches and our records and everything work together to give you new ways to process information in your programs, but also they work really nicely with object-oriented stuff that already exists in Dart. So it kind of melds very seamlessly, and it makes Dart as an object-oriented language more useful and also gives you the opportunity to use these functional features. So now we know how to use records and object patterns, both ways to make your code better in Dart. More succinct, easier to write, sometimes more powerful. The final Dart 3 feature we're going to talk about today is called exhaustiveness checking, which I kind of hinted at earlier when I said that it was hard to keep track of the different combinations of questions and their answer property types. So let me show you what that means. So even though this is the code that we just went through, even though it's cleaner and neater than some messy if-else chain, it's still pretty complex. It's hard to just look at it and know that you've accounted for every question subtype and every answer subtype, and it'd be easy to imagine that others could be added that you wouldn't know about, and that would mean more combinations and more cases and more possibilities to miss something or forget something. So exhaustiveness checking is meant to address exactly that issue. What it does is it lets the compiler alert you if you're missing any possible cases for the values that could flow through this switch. So this switch is switching over a question object, so it lets you know if you're missing a case or a type that a potential question object could take. So for example, if we comment out this third example here, the compiler will give you this error. So it says the type question is not exhaustively switched by the switch cases because it doesn't have image question Boolean answer. So this is really nice. And it tells you this as you're writing your code. So you never have to worry, am I missing a case? Did I account for everything? It'll let you know before you ever have to run into that error. But how does it do this? Because technically you can extend or implement a class from anywhere in Dart, right? So how can the compiler really be sure that it's exhaustively aware of all the possible cases? So the way exhaustiveness checking works in Dart 3 is, of course, because of patterns and because of switches, but also thanks to this new class modifier, sealed. So if you put this modifier on a base class in a class hierarchy, then you can only create subtypes of that class in the same library. So that guarantees 100% for sure that the compiler knows that these are all the subtypes for these classes. So then it can tell you that you're missing something because it's aware of them. So exhaustiveness isn't actually new in Dart. Technically, like even before Dart 3, you could write a switch over a Boolean type without a default case because there's only 2 types it can take. So the compiler is always aware that this is a complete exhaustive switch. And the same goes for enums, because once you declare an enum, it's immutable, it can't change. So in this switch, for example, I forgot a case for fish. So actually, even before Dart 3, you would get an error here too, and telling you that this switch is not exhaustive over the type. So now custom types are just as cool as Booleans and enums, and they can be exhaustively switched over. So this not only helps, again, like I said, while you're writing the switch, but also if somebody else adds a new type to that class hierarchy that you weren't aware of, the compiler will immediately alert you that you're missing a type. So it kind of is another way to like keep whoever's maintaining the library in sync with whoever's writing this code that's using those types. And also, because of the security guarantee that this is exhaustive, you don't need default cases when you're switching over an exhaustive pattern. So that's all the features: exhaustiveness checking, patterns, switches, and records. We weren't going to include another example, but as Eric was writing the app code, he actually was trying to implement this specific UI thing, and it didn't work out well, and he realized that all of the things that we're talking about would actually be a great solution for it. So we thought some app developers would get a kick out of that. So he was trying to implement like the button change colors for like when you press a button, it changes colors, or when you're hovering over it, or when you select the wrong answer or the correct answer and the rest are grayed out, et cetera, et cetera. So there's like 6 different colors and 4 different buttons and different situations that lead up to each, and sometimes some of the values don't matter and sometimes they do matter. So he started writing a if-else case, just to, like you always do, and immediately made a mistake, and he wrote isActive. He wrote 2 cases for isActive, and he realized that, well, 1, if he finished writing out this structure, it would be really, really long and complicated. And 2, if he had been using something where exhaustiveness checking was active, then it would have immediately alerted him that he wasn't accounting for one of these states. So we tried it with exhaustiveness checking. And we wrote this record of our Boolean states. So is active, is pressed, et cetera. They can all be true or false. So this is exhaustive.
So cool.
It is cool. Yeah, so we wrote a record of Boolean types. And like I just described, Booleans are exhaustive because they can only be one of 2 types. And we switched over it. And then what we did here is we use wildcard patterns. So a wildcard pattern, just an underscore in your pattern, lets you account for a value that you're matching against, but it doesn't matter what the value is and you don't want to do anything with it. So without wildcards, we would have had to write out the 25 possible combinations of these true or false Boolean values. But with them, we only need to write out the 6 that matter to us because of the combinations of whatever the state is. So yeah, that was pretty cool. The switch is exhaustive, again, like I said, because of the Booleans. And the logic is like still kind of complicated. If you don't know what you're looking at, it's still hard to read. But look at that. Now you all do know what you're looking at. But the analyzer will tell you if you're missing a case again. So like if we commented this one out, you'll get this type bool, 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 bool. It's not exhaustively. Like, how are you supposed to know what that means? But it'll tell you exactly which type you're missing. You're missing a true, false, true, true, true. But again, thanks to wildcards, you don't even need to worry about that. So what did we learn? Who wants to repeat it back to me? Just kidding. So yeah, we learned that pattern matching. Oops. Pattern matching is cool. We learned that pattern matching lets you, or not lets you, but it provides you with way more robust validation than just manually using an if-else chain, and makes validating complex structures really easy and neat. And then we learned that our updated switches can turn, again, messy if-else chains into like neat declarative blocks that confirm your conditions and can simultaneously extract data from objects so you can use it right there. We learned that records let you return multiple values, which is not something you were able to do in a lightweight manner before in Dart. And you can even return them from functions. And then finally, exhaustiveness checking tells you when you're missing a case in your switch. And because of sealed classes, you can seal a class hierarchy, meaning that you can create exhaustive custom types in Dart and makes your code safer, easier to write because it's warning you as you're writing it, and yeah, easier to read sometimes too, if you understand that. So some pretty cool features in Dart 3. If you like this talk and want to learn more about this subject, it's a complicated subject, so it helps to have something to read. There's a code lab about it. The code lab is a little bit simpler than the examples that I gave you. It's called Dive into Dart's Patterns and Records. And it's more like basic Flutter stuff. If you are interested in the functional part of this talk, there's a very deep dive into why functional programming, or how functional programming can be kind of imitated and replicated with Dart 3, including some really advanced functional paradigms like algebraic data types. And of course, there's the Dart documentation. That's, it's not complete, but it's pretty good. There's good reference information there. And if you didn't like the talk, please direct all your complaints to my colleague, Eric. Thank you. That's it.